Welcome to Chemical Bonding with Miriam Dewam and Millie Marie Pena. Today we're going to talk about the four types of bonds of chemicals consisting of metallic bond, ionic bond, covalent network, and molecular covalent bonds.
Welcome to the Chemical Bonding Show with your host, Millie Marie Pena.
Okay, so we're going to start off with metallic bonds, and here with us today we have lithium and magnesium. So lithium and magnesium, tell us what types of bond you guys make.
Hi, my name's Lithium, and this is my twin sister Magnesium. We are metal atoms, and our special powers consist of electricity. But we don't dissolve in water.
Thanks, Lithium, for your great answer. Magnesium, what happens to the electrons in each type of your guys' bond?
Electrons form a sea of delocalized electrons around our nuclei.
Thanks, Lithium and Magnesium, for helping us out with the few questions we had. Our next thing that we're going to do with metallic bonds is to show you guys how each type of bond is created. Welcome back to Chemical Bonding. We're going to do a quick experiment with lithium, and she's going to show us if she dissolves in water or not because she's a metallic bond.
A chemical bond forms when two or more atoms rearrange valence electrons to increase stability.
So for the first step of our lab, we're going to take purple food coloring and some water in a clear bowl. And we're just going to drop a few drops in. And you're going to stir it up. And then Lithium is going to take her foot and put it in there and see if she dissolves in water or not. So we're going to take Lithium's foot out now, and you can tell that her foot did not dissolve, it's still there. And that shows one characteristics of metallic bonds that do not dissolve in water. So now that we've finished with our first characteristic, now we're going to start with our second. You're going to take pepper, if you want to do this lab at home, any household item, and we're going to pour a little bit of pepper in our purple water. And you can see it in there. And I'll go ahead and stir it around. So it's just sitting in there right now, and I'll give it about a few more seconds. And you can tell that the pepper did not dissolve in the water, which means it is a metallic bond along with lithium. Welcome back to the Chemical Bonding Show. Here's your co-host, Miriam Dewam.
Hello. Our next segment on the Chemical Bonding Show, we will be discussing ionic bonding. And two of our guests we have here are beryllium, who is a metal atom, and Big O, who is a non-metal atom.
Thanks, Miriam. Hi, I'm Big O, and this is my cousin, Beryllium.
All right, thank you, Oxygen. I have a question for you as well. What types of atoms form in your type of bond?
The answer to that question is that we dissolve in water and we conduct electricity, but only when we are dissolved. So we form when a non-metal and a metal come together, and we dissolve in water and conduct electricity, but only when we are dissolved in water.
All right, thanks, Oxygen, for your answer. Beryllium, I have a question for you. What happens to the electrons in your types of bonds?
Our electrons are transferred from the metal atom to a non-metal atom.
In this experiment, we will be using our first example. Oxygen has gladly volunteered to see if his leg will dissolve in water or not.
An ionic bond forms when valence electrons are transferred, giving from one atom to another.
In this experiment, we have a container of turquoise food coloring and a container of pure clear water. We will use the food coloring and pour a drop or two into the container, and we will stir it with a spoon to make our element water. And now we will determine to see if Oxygen here, his leg, will dissolve in water. Okay. Sad to say, Mr. Oxygen's foot did dissolve in water, like an ionic bond should, but it also conducted electricity. Our next example is a lab that you can do at home if you don't have friends like we do. You can take just regular salt and pour it into the container of colored water and then stir it around, and you can tell that there's nothing there because it already dissolved in water, and it also conducts electricity. Welcome back to the Chemical Bonding Show with your host, Millie Pena.
Hi, welcome back. So for this part, it's our third part, we're going to do molecular covalent. With us for molecular covalent, we have carbon and fluorine with us today. So carbon, I have a question for you. What types of atoms form each type of your guys' bond?
Hi, I'm Carbon, and this is my twin brother, Fluorine. We are non-metal atoms, and together we form molecular covalent bonds. We do not conduct electricity when dissolved or when not dissolved in water.
Thanks, Carbon, for that great answer. Fluorine, I have one more question to ask, and that's what happens to your guys' electrons in your guys' bond?
Our electrons are shared between atoms.
Thanks, Carbon, for that great answer. Fluorine, one of our fans wants to know what happens to your electrons in each type of bond.
Our electrons are shared between atoms.
Great answer. Stay tuned for the lab that we'll have coming up. We're going to do a lab with Fluorine here, and he's going to show us if his foot dissolves in water or not.
In covalent bonds, electrons are shared, forming molecules.
For this lab with Fluorine, we're going to take some water in a clear bowl, some orange food coloring or any food coloring you have at home, and just drop a few drops in it, 1 or 2, and then you're going to stir it up with a spoon. And then once you get the orange color, I'm just going to take Fluorine and I'm going to dip his foot in orange water. So now we're going to take out Fluorine's foot and see if it dissolved in water or not. And you can see that his foot did dissolve in water because it is a molecular covalent bond. So you can be able to do this lab at home, and all you're going to need to do is get food colored water that's orange and some garlic salt. And you're just going to open up the garlic salt and sprinkle some of the flakes in. And you're going to swish it around for about 30 seconds. And you're going to be able to see that the flakes are slowly dissolving. And I'm going to pick some up, and you can see that there is no more flakes because of the molecular covalent bond. Welcome back to the Chemical Bonding Show. Here's your co-host, Miriam Dewin.
Hello, welcome back, and we will be discussing covalent network bonding with our two special guests, nitrogen and chlorine, who are both nonmetals. Alright, let's start off with our first fan mail for nitrogen. The first question is, what types of atoms form each type of bond?
Us as covalent network bonds, we form between 2 or more nonmetal atoms, and we do not dissolve in water or conduct electricity.
Alright, our next question and our final question is for chlorine. Chlorine, your fan asks, what happens to the electrons in each type of bond?
Our electrons are tightly shared between our atoms.
Alrighty, thank you. Stay tuned for the lab. In this experiment, we will determine whether chlorine's leg dissolves in water or not. For this experiment, we will take just a regular cup of water and pink food coloring, and we will put 1 to 2 drops of food coloring in here. And then we will take our spoon and stir it for about 20 seconds or so. And now we will determine if chlorine's leg here will dissolve in water or not. As you can see, chlorine's leg did not dissolve in the water because it is a solid, which is a network covalent bond. In this example, for the lab, we will determine whether gobstoppers can dissolve in water or not. First, you take your food coloring, whatever color, and you pour it into your water. And then you take your gobstoppers and you just put them all in your water. You can either stir them or let them sit there. And in about 20 seconds, check them, and you can tell that they have not dissolved, which means they are a network covalent bond. Thanks for watching the Chemical Bonding Show, guys.
See you next time.